Welcome back everyone. Today we are going to see the interface of Aspen Exchanger Design and Rating, that is Aspen EDR of version V14. So here we can see this is the interface. We can see here we have different options available where we can find the designing of different exchangers. We have shell and tube mechanical, we have plate and fin type heat exchangers, we have coil wound, air coiled, fired heater, then we have budget cost estimation for the exchanges design and much more options. Here we can do the customizations of our current and simulated heat exchangers that we already did. In the resources section, we can see what is new in the Aspen EDR, then different examples provided by the Aspen Tech. We can go ahead for the Aspen support and can find the help. Now we are going to see and rate the shell and tube heat exchanger. So we will click here on create and the interface of Aspen EDR will open. So this is the interface of Aspen EDR where we can find too many options which will help us to create, design, rate and simulate our heat exchangers. In the SI unit sections, we can define our parameters according to the units. Here we have selected US SI systems. Then here we can provide our process data, the process properties, set geometry. Here we can run, control and stop our process. In the run mode, we can see here we have 4 different options, that is design, rating and checking, find fouling and simulation. Also we can see here we have different type of model provided that we already discussed in our introduction video. Here we can find the parameters that are provided, like we can see the TEMA input that we have provided. Here we can see the datasheet that has been generated while rating our exchanger. So if we click on the shell and tube, here we can see we have different options available to provide the input data according to our TEMA sheet, which is already provided by the customer. So here we can see we have different types, that is bonnet for the exchangers, B, C, D. Then we have shell passes here. And again we have the different parameters for the same. So here we can give our location of hot tube, that is tube side and shell side. We can provide the geometry for the tube OD and pitch, the diameter provided. Then we can see the tube patterns that are been differentiated in different angles. Then we have baffle types, we have rod type and unbaffled type. Then we have segmental, double segmental and triple segmental. Also we can do find the MOC, that is carbon steel SS304 and SS316. So we generally use stainless steel 316. Then we can do some sizing for the design. We can do shell ID and OD. Then we can define the number of tube passes and we can find our overall result, that is the total cost for the heat exchanger developed. So here we can find the process that we have obtained from the inputs that we provided. So as we have not provided any input data, here we can see our interface is in blue. So this is the section error and warning where we will find the message generated by the system. In the results section, we can see the descriptions of overall exchanger that we have designed. Then we have optimization path. Then we have tema sheet, which is the most important in our case. Tema sheet provides us the necessary information of the heat exchangers that we have rated, simulated, and modeled. Also, we can find the overall summary of the given heat exchangers in here. So further we can see we have thermal summary, hydraulic summary, and mechanical summary, where we can find different results obtained from the exchangers that we have rated. Also, we can find the resistance distribution on shell side and tube side from the resistance distribution tab. Then we can find the hot stream and cold stream composition and overall performance from the overall performance tab. So this is the interface of Aspen EDR, where we can provide the process data and can find our optimum result of the heat exchangers designed. In the last, we can see we have the warning messages that we obtain. As such, we have not provided any data. We find that no data input has been provided for the given parameters.